A carbide burr tool is an essential instrument in tool and die repair because it allows skilled technicians to restore worn, chipped, or damaged tooling by precisely removing defects and reshaping critical surfaces back to their original specifications. Tooling and dies used in manufacturing are subjected to extreme pressure, friction, and repeated cycles, which over time can lead to wear, galling, cracking, or deformation of the working surfaces. A carbide burr tool mounted on a high-speed die grinder provides controlled, aggressive cutting capability that makes it possible to selectively remove damaged material without compromising the overall geometry of the tool. Because carbide is extremely hard and wear-resistant, it remains effective even when working on hardened tool steels commonly used in dies, molds, punches, and forming tools. In tool and die repair, a carbide burr tool is especially valuable for restoring functional geometry in critical areas such as cutting edges, forming cavities, and alignment surfaces. When a die becomes worn or chipped, it can produce defective parts or cause improper forming during production. The carbide burr tool allows the technician to carefully grind away damaged sections, blend transitions, and reestablish smooth, accurate contours that are necessary for proper operation. This level of precision is crucial because even minor deviations in surface geometry can affect part quality, tolerances, and repeatability in high-volume manufacturing environments. The tool's ability to access tight corners and intricate shapes also makes it ideal for repairing complex tooling designs that cannot be restored with larger machining equipment. A carbide burr tool also plays a key role in extending the service life of expensive tooling and dies by enabling localized repairs rather than full replacement. Instead of scrapping a damaged die or mold, technicians can use carbide burrs to remove stress cracks.
A carbide burr tool is frequently used in metal sculpting because it gives artists and metal workers the ability to carve, shape, and texture metal with a level of precision and control that is difficult to achieve with other hand or power tools. In sculptural metalwork, materials such as steel, aluminum, bronze, and stainless steel are often formed into rough shapes through welding, forging, or fabrication processes. But these initial forms typically require extensive refinement to achieve the final artistic vision. A carbide burr tool mounted on a die grinder allows the artist to remove material in a highly controlled way, gradually refining contours, defining edges, and bringing out detailed forms within the sculpture. The hardness of carbide ensures that the tool remains effective even when working on tough or work-hardened metals, making it suitable for both rough shaping and fine detailing. In metal sculpting, a carbide burr tool is especially valuable for creating texture and depth within a piece. Artists often use different burr shapes to carve lines, grooves, patterns, and organic textures into the surface of the metal, adding visual interest and dimensional complexity. The tool can be used to smooth transitions between welded sections, blend different components together, or deliberately add surface variation that enhances the artistic expression of the sculpture. This versatility allows sculptors to move fluidly between aggressive material removal and delicate surface detailing, depending on the creative intent of the piece. A carbide burr tool also plays an important role in refining the overall form and balance of a sculpture. Many metal sculptures begin as welded assemblies or fabricated frameworks that must be carefully shaped to achieve proper proportion and flow. The carbide burr tool allows the artist to adjust curves, soften harsh transitions, and define contours that give the sculpture its final character.
A carbide burr tool is essential in die and mold making because it allows highly skilled tool makers to refine, adjust, and finish complex cavities and contours in hardened tool steels that would otherwise be extremely difficult to machine. Dies and molds are used to mass-produce parts in industries such as automotive, aerospace, consumer goods, and industrial manufacturing, and they must be manufactured with extreme precision to ensure consistency, accuracy, and repeatability. After initial machining operations, such as CNC milling or EDM, electrical discharge machining, a carbide burr tool is often used for fine detailing, allowing the toolmaker to smooth transitions, sharpen features, and correct minor imperfections within hardened steel cavities. Because carbide is significantly harder than standard steel, the carbide burr tool can effectively cut and shape these hardened surfaces without losing its cutting efficiency. In die and mold making, a carbide burr tool is particularly valuable for refining intricate internal geometries that require both precision and control. Mold cavities often include tight corners, complex curves, and detailed textures that must be carefully adjusted to achieve the desired final product shape. The carbide burr tool enables the operator to selectively remove small amounts of material, improving surface definition and ensuring that all features meet exact design specifications. This level of control is critical when producing molds for plastic injection molding, metal stamping dies, or forging dies, where even minor surface imperfections can affect part release, dimensional accuracy, or surface finish of the final manufactured product. A carbide burr tool also plays a key role in improving surface quality and reducing stress concentrations within die and mold components. After rough machining, surfaces may contain tool marks, sharp transitions, or uneven areas that could lead to wear, cracking, or premature failure.
A carbide burr tool is widely used in knife making because it provides knife makers with the ability to shape blade profiles, refine bevels, and create precise contours on both raw and hardened steel blades with a high degree of control. During the early stages of blade fabrication, after the steel has been cut into a rough shape, a carbide burr tool mounted on a die grinder allows the maker to quickly remove excess material and establish the basic outline of the blade. This includes defining the spine, tip, and overall profile before moving into finer finishing stages. The aggressive cutting ability of carbide makes it especially effective for working with tough knife steels, including high carbon steel, stainless steel, and heat-treated alloys, where traditional hand filing would be much slower and less efficient. In bevel shaping, a carbide burr tool plays a critical role in establishing and refining the primary and secondary bevels of a knife edge. Bevels determine how the blade tapers down to the cutting edge, directly influencing sharpness, durability, and cutting performance. Using a carbide burr tool, knife makers can carefully grind and adjust bevel angles, ensuring symmetry and consistency along the length of the blade. This level of precision is essential for producing functional knives that cut efficiently and maintain edge stability. The tool also allows for gradual refinement, meaning material can be removed in small, controlled amounts to avoid overheating or damaging the steel's temper during shaping. A carbide burr tool is also valuable for adding detailed contours and ergonomic features to knife designs. Many custom knives include finger grooves, handle transitions, choils, ricassos, and decorative shaping that require careful material removal in tight or curved areas. The variety of carbide burr shapes allows knife makers to access complex geometries and refine these features with precision.
A carbide burr tool is highly effective for aluminum port and passage work because it allows technicians and performance builders to precisely enlarge, shape, and smooth internal ports, passages, and channels in engine and industrial components made from aluminum. Aluminum is widely used in intake manifolds, cylinder heads, throttle bodies, and various industrial housings due to its lightweight properties and excellent thermal conductivity. However, cast or machined aluminum parts often contain restrictions, rough internal surfaces, and casting imperfections that can limit airflow or fluid movement. A carbide burr tool mounted on a high-speed die grinder enables controlled material removal, allowing the operator to carefully open up restrictive areas and refine internal pathways without compromising the structural integrity of the component. In port and passage work, a carbide burr tool is particularly valuable for improving flow efficiency by smoothing transitions and reducing turbulence within aluminum components. Air, fuel, coolant, or other fluids moving through these passages perform more efficiently when internal surfaces are clean, consistent, and free of abrupt changes in direction or rough textures. By using a carbide burr tool, technicians can gradually reshape ports to create a more streamlined flow path, which enhances performance in engines by improving volumetric efficiency, throttle response, and overall power output. In industrial applications, smoother passages can also improve cooling efficiency, hydraulic performance, or fluid transfer rates, depending on the system design. A carbide burr tool is also essential for accessing and refining complex internal geometries that are common in aluminum components. Many intake and exhaust passages include tight bends, narrow channels, and deep cavities that cannot be reached with conventional grinding or sanding tools.
A carbide burr tool is commonly used in foundry casting cleanup because it efficiently removes casting flash, excess metal, and surface imperfections that remain on components after the casting process. When metal parts are produced through casting, molten metal is poured into molds where it cools and solidifies into the desired shape. However, this process often leaves behind unwanted material such as thin fins of metal known as flash, as well as rough edges, gate remnants, and minor surface defects caused by mold seams or imperfections in the casting cavity. A carbide burr tool mounted on a die grinder allows operators to quickly and accurately remove these excess materials while maintaining control over the final shape of the component. Its sharp cutting edges are capable of handling tough cast materials such as iron, steel, aluminum, and bronze, making it a reliable tool for heavy-duty cleanup work. In foundry environments, a carbide burr tool is especially useful for refining the surface of cast parts that require further machining or finishing. After the initial casting cleanup, components often need to meet tighter dimensional tolerances or aesthetic requirements before they can be used in final assemblies. The carbide burr tool helps smooth rough transitions, eliminate raised imperfections, and blend areas where excess metal has been removed, ensuring that the part is properly prepared for secondary processes such as machining, grinding, painting, or coating. This is particularly important in industries like automotive manufacturing, heavy equipment production, aerospace casting, and industrial machinery, where cast components must meet strict performance and safety standards. A carbide burr tool also provides significant advantages when working with complex cast shapes that contain internal cavities, curves, and hard-to-reach areas. Casting processes often produce intricate geometries that cannot be easily cleaned with flat grinding tools or abrasive wheels.
A carbide burr tool is highly valuable in industrial equipment maintenance because it provides technicians with the ability to modify components, remove damaged material, and prepare surfaces quickly and precisely during repair and servicing operations. Industrial machinery is often subjected to heavy loads, vibration, heat, and continuous operation, which can lead to wear, cracking, deformation, corrosion, or impact damage over time. When these issues occur, a carbide burr tool mounted on a die grinder allows maintenance personnel to selectively remove compromised material without dismantling entire systems or replacing large assemblies. Its aggressive cutting ability makes it effective on hardened steels, cast iron housings, aluminum components, and other tough industrial materials commonly found in heavy equipment. In equipment modification and repair work, a carbide burr tool is especially useful for restoring proper fit and function to worn or damaged parts. Bearings, housings, mounting points, and structural brackets may become worn or misaligned, affecting machine performance and reliability. The carbide burr tool allows technicians to carefully reshape surfaces, correct uneven wear patterns, and remove burrs or deformation that interfere with proper assembly. This level of precision is essential in industrial environments where even small deviations can lead to vibration issues, reduced efficiency, or premature failure of equipment. By enabling targeted material removal, the tool helps restore components to usable condition without requiring full replacement. A carbide burr tool also plays an important role in preparing surfaces for welding, reinforcement, or fabrication during maintenance procedures. When cracks, corrosion, or broken sections are identified, the affected area must be cleaned and shaped before repair work can begin. The carbide burr tool is used to grind away rust, scale, and weakened metal, creating a clean, stable surface for welding.
A carbide burr tool is an important asset in shipbuilding repairs because it enables technicians to prepare weld joints, remove damaged metal, and perform precise structural restoration work on large marine vessels. Ships are constantly exposed to harsh environments, including saltwater, humidity, and mechanical stress, which can lead to corrosion, fatigue cracks, impact damage, and general wear over time. When repairs are needed, a carbide burr tool mounted on a high-speed die grinder allows shipyard workers to aggressively yet accurately remove compromised material, clean up damaged sections, and reshape metal surfaces so they are ready for welding or reinforcement. Its cutting ability is especially valuable on thick steel plating commonly used in hulls, bulkheads, and structural frames, where material removal must be both efficient and controlled. In weld joint preparation, a carbide burr tool plays a critical role in ensuring strong, reliable repairs. Before welding can be performed on damaged or worn areas, the metal must be properly cleaned and shaped to allow for full penetration and bonding. The carbide burr tool is used to remove rust, paint, corrosion, and irregular edges around the repair zone, creating a clean and properly beveled surface for welding. This helps ensure that new welds integrate effectively with the existing structure, restoring strength and structural integrity. Proper joint preparation is especially important in shipbuilding because weld quality directly affects the safety and durability of the vessel under heavy loads and ocean conditions. A carbide burr tool is also highly effective for removing damaged or weakened metal during structural repairs. Sections of a ship's hull or internal framework that have been compromised by corrosion or impact may need to be cut away and reshaped before replacement material is installed.
A carbide burr tool is widely used for chamfering edges because it allows machinists and fabricators to create precise edge breaks on machined parts, improving both assembly fit and overall part safety. After machining operations such as milling, turning, or drilling, parts often have sharp 90-degree edges that can interfere with assembly or pose handling hazards. A carbide burr tool mounted on a die grinder enables controlled material removal along these edges, producing a consistent chamfer that softens the transition between surfaces. The hardness and sharp cutting ability of carbide make it effective for quickly removing small, controlled amounts of material while maintaining accuracy and preventing damage to the part's critical dimensions. In chamfering applications, a carbide burr tool is especially important for improving assembly efficiency and ensuring proper alignment between mating components. Sharp edges can prevent parts from seating correctly or cause binding during installation, especially in precision assemblies where tight tolerances are required. By creating a chamfer, the carbide burr tool helps guide fasteners, shafts, and mating surfaces into position more easily, reducing assembly time and minimizing the risk of cross-threading or misalignment. This is particularly valuable in industries such as automotive manufacturing, aerospace engineering, tool and die work, and general machining, where consistent and repeatable assembly performance is essential. A carbide burr tool also enhances safety by eliminating sharp edges that could cause injury during handling or maintenance. Machined parts with exposed edges can easily cut or abrade skin, gloves, or other materials during transport, inspection, or installation. By breaking these edges with a controlled chamfer, the carbide burr tool helps create a safer working environment and reduces the likelihood of damage during downstream processes. A carbide burr tool is highly effective for surface blending because it allows technicians and fabricators to seamlessly smooth transitions between welded, machined, and repaired surfaces, creating a uniform and visually consistent finish. In many metalworking applications, components are made up of multiple processes and materials, such as welded joints, CNC machined sections, and manually repaired areas that often do not naturally align in surface height or texture. These differences can create visible ridges, uneven transitions, or abrupt changes in contour that not only affect appearance, but can also interfere with function. A carbide burr tool mounted on a die grinder enables controlled material removal, so these variations can be gradually leveled and blended into a continuous surface without removing excessive material from the base component.
In surface blending work, a carbide burr tool is especially valuable for eliminating the harsh transitions that occur at weld seams or repair zones. Welded areas often sit slightly higher than surrounding metal due to bead buildup, while machined surfaces are typically smoother and more uniform. The carbide burr tool allows the operator to carefully reduce these high spots and feather the edges between different surface regions, creating a gradual transition rather than a sharp step. This process is critical in applications where both function and appearance matter, such as automotive fabrication, industrial equipment repair, architectural metalwork, and custom manufacturing. A well-blended surface not only looks more professional, but also reduces stress concentrations that can form at abrupt geometric changes. A carbide burr tool is also useful for refining repaired areas where metal has been filled, welded, or reshaped during restoration. These repair zones often have slight inconsistencies in texture or elevation compared to the original material.
A carbide burr tool is widely used in metal fabrication shaping because it provides precise, controlled material removal when working with steel, aluminum, stainless steel, and other metals during custom fabrication projects. Fabricators often need to modify raw stock or preformed components to achieve exact dimensions, smooth transitions, or complex contours, and a carbide burr tool mounted on a die grinder allows them to do this with a high level of accuracy. Its sharp, aggressive cutting edges are capable of quickly removing material while still giving the operator fine control over depth and direction, making it ideal for shaping brackets, housings, frames, and structural components that require both strength and precision. In metal fabrication shaping, a carbide burr tool is especially valuable when refining edges, blending welds, and creating smooth transitions between joined parts. After pieces are cut, welded, or machined, they often require additional shaping to ensure proper fit and alignment. The carbide burr tool allows the fabricator to gradually sculpt metal surfaces, removing high spots, correcting imperfections, and adjusting geometry without the need for large-scale grinding equipment. This is particularly important in custom fabrication work where no two parts are exactly the same, and adjustments must often be made by hand to achieve a perfect fit. The tool's ability to reach tight corners, curved surfaces, and internal cavities makes it essential for detailed shaping work that larger grinders cannot easily accomplish. A carbide burr tool also plays a key role in refining the aesthetic quality of fabricated metal components. Beyond structural accuracy, many fabrication projects require a clean, professional finish before painting, powder coating, or final assembly. The carbide burr tool helps smooth rough edges, remove machining marks, and blend weld seams into surrounding surfaces, resulting in a more uniform and visually appealing final product.
A carbide burr tool is widely used in aerospace component finishing because it provides the precision, control, and cutting efficiency required to work with advanced materials such as titanium, Inconel, and other high-strength aerospace alloys. These materials are commonly used in aircraft structures, turbine components, and critical engine parts due to their exceptional strength-to-weight ratio and resistance to extreme temperatures. However, the same properties that make them ideal for aerospace applications also make them extremely difficult to machine and finish. A carbide burr tool mounted on a high-speed die grinder allows technicians to carefully grind, shape, and refine these components with accuracy while maintaining strict dimensional tolerances. The hardness of carbide ensures that the cutting edges remain effective even when working against tough, heat-resistant metals that would quickly wear down standard tooling. In aerospace finishing, a carbide burr tool is essential for refining complex geometries, removing machining marks, and improving surface transitions on precision-engineered parts. Aerospace components often feature intricate designs with tight radii, internal passages, and thin-walled structures that require careful finishing to meet performance and safety standards. The carbide burr tool enables operators to selectively remove small amounts of material, smooth rough edges, and blend transitions without compromising the structural integrity of the part. This level of precision is critical because even minor surface imperfections can create stress concentrations that may lead to fatigue, failure under high load, or vibration conditions experienced during flight. A carbide burr tool also plays an important role in preparing aerospace components for further processing, such as coating, inspection, or assembly. Many aerospace parts require specialized surface finishes to improve corrosion resistance, reduce friction, or enhance performance.
A carbide burr tool is highly effective for rust and corrosion removal because it can aggressively cut through oxidized layers, scale, and surface contamination while still allowing the operator to maintain precise control over how much base metal is removed. In restoration and repair work, metal components that have been exposed to moisture, chemicals, or environmental conditions often develop rust and corrosion that penetrates the surface and creates rough, weakened areas. A carbide burr tool mounted on a die grinder or rotary tool allows technicians to quickly strip away these damaged layers, exposing clean, solid metal underneath. Unlike wire brushes or sanding discs that may only polish the surface, a carbide burr tool physically removes the degraded material, making it especially useful for heavily rusted parts where deeper cleaning is required. When removing corrosion, a carbide burr tool is valuable because it can reach into pitted surfaces, tight corners, seams, and irregular shapes where rust tends to accumulate. Corrosion often forms unevenly, creating pockets and scaling that are difficult to eliminate with flat grinding tools. The variety of carbide burr shapes allows the operator to follow the contours of the part and selectively remove rusted material without unnecessarily thinning or damaging surrounding areas. This level of precision is particularly important in automotive restoration, marine repair, industrial maintenance, and structural steel repair, where preserving as much original material as possible is essential for maintaining strength and integrity. A carbide burr tool also helps prepare metal surfaces for welding, coating, or refinishing after rust removal. Once corrosion is removed, the surface often needs to be cleaned and smoothed to ensure proper adhesion of paint, primer, powder coating, or protective sealants.
A carbide burr tool is extremely useful in broken bolt removal because it provides the cutting power and precision needed to grind away seized, snapped, or stripped bolts and studs when traditional extraction methods fail. In many repair situations, bolts can become corroded, over-tightened, or heat-seized within threaded holes, causing them to break off flush with or below the surface of the surrounding material. This makes conventional removal tools such as extractors, wrenches, or pliers ineffective. A carbide burr tool mounted on a high-speed die grinder allows the technician to carefully grind down the remaining bolt material, gradually reducing it until it can be removed or the threads can be salvaged. The extreme hardness of carbide makes it capable of cutting through hardened fasteners, even those made from high-strength steel alloys. In broken bolt removal, a carbide burr tool is especially valuable for working in confined or awkward spaces where precision is critical. Broken bolts often sit deep within engine blocks, machinery housings, exhaust manifolds, or structural assemblies where access is limited. The variety of carbide burr shapes allows the operator to reach into these tight areas and selectively remove bolt material without damaging the surrounding threads or base metal. By working slowly and with controlled pressure, the technician can grind away the bolt while preserving as much of the original threaded hole as possible, which may allow for retapping or thread repair inserts later in the process. A carbide burr tool also plays an important role in reducing overall repair time and avoiding more destructive removal methods. Alternative techniques such as drilling out bolts or using heat and extraction tools can sometimes damage the surrounding material or require complete remachining of the threaded area. The carbide burr tool offers a more controlled approach, allowing for gradual material removal.
A carbide burr tool is commonly used in exhaust fabrication because it allows fabricators to smooth internal weld seams, blend joints, and refine transitions inside exhaust systems in order to improve overall exhaust flow efficiency. During the construction of exhaust headers, pipes, mufflers, and custom exhaust systems, welding is required to join sections of tubing, flanges, and collectors. These welds often leave behind internal ridges, uneven bead penetration, or slight misalignments that can disrupt the smooth movement of exhaust gases. By using a carbide burr tool mounted on a die grinder, the fabricator can reach into tubing and carefully remove these internal imperfections without excessively thinning or weakening the surrounding metal. The hardness and cutting efficiency of carbide make it especially effective for working inside stainless steel and mild steel exhaust components, where precision material removal is required. In exhaust fabrication, airflow efficiency is extremely important because any restriction or turbulence inside the system can negatively affect engine performance, throttle response, and overall efficiency. A carbide burr tool helps create smoother internal surfaces by blending weld seams and transitions between pipe sections, reducing sharp edges and abrupt changes in diameter that can slow or disrupt exhaust gas flow. This smoother internal path allows gases to exit the engine more freely, improving scavenging efficiency and reducing back pressure. As a result, engines can breathe more effectively, which can lead to improved horsepower, torque, and fuel efficiency, especially in performance or racing applications where exhaust flow optimization is critical. A carbide burr tool is also particularly useful in areas of the exhaust system that are difficult to access with larger grinding tools.
A carbide burr tool is a fundamental instrument in cylinder head porting because it allows engine builders and performance technicians to precisely reshape, smooth, and optimize the intake and exhaust ports within a cylinder head. These ports are responsible for directing air and fuel mixture into the combustion chamber and expelling exhaust gases after combustion, and their shape, surface quality, and size have a direct impact on engine efficiency and power output. Using a carbide burr tool attached to a high-speed die grinder, the operator can carefully remove material from cast aluminum or iron cylinder heads, gradually enlarging and refining the ports to improve airflow characteristics. The aggressive cutting ability of the carbide burr tool makes it especially effective for removing casting imperfections, ridges, and restrictions that are commonly found in factory cylinder heads. During the porting process, a carbide burr tool is used to reshape the intake and exhaust runners to create a smoother and more efficient airflow path. By carefully grinding and blending the internal surfaces, sharp turns, rough textures, and sudden changes in port geometry can be reduced or eliminated. This helps air and exhaust gases move more freely through the engine, reducing turbulence and increasing volumetric efficiency. Improved airflow allows the engine to burn fuel more effectively, which can result in increased horsepower, better throttle response, and improved overall performance. The carbide burr tool also enables precise control, allowing the technician to remove small amounts of material at a time while maintaining consistent port dimensions and avoiding over-reshaping that could negatively affect engine performance. A carbide burr tool is particularly valuable in performance tuning because different engine designs require different porting strategies.
A carbide burr tool is commonly used for weld removal because it can quickly and efficiently cut through hardened weld material while maintaining excellent control and precision. After a welding operation is completed, excess weld metal, uneven weld beads, spatter, and high spots often remain on the surface of the workpiece. A carbide burr tool mounted in a die grinder allows fabricators, welders, and metal workers to remove these imperfections without damaging the surrounding base metal. The sharp cutting edges of the carbide burr tool aggressively shave away excess material, making it ideal for leveling welds on steel, stainless steel, cast iron, aluminum, and other metals. Unlike grinding wheels that can remove material over a broad area, a carbide burr tool provides targeted material removal, allowing the operator to focus on specific sections of the weld with greater accuracy. When smoothing weld beads, a carbide burr tool helps create a cleaner and more professional appearance by blending the weld into the surrounding metal surface. This is particularly important in industries such as automotive fabrication, aerospace manufacturing, structural steel construction, and custom metal fabrication, where both strength and appearance matter. The carbide burr tool can be used to gradually shape the weld profile, eliminate rough edges, and remove sharp transitions that could interfere with assembly or create stress concentrations. Its ability to reach corners, tight spaces, curved surfaces, and difficult to access areas makes it especially valuable when working on complex weldments where larger grinding tools may not fit. A carbide burr tool is also frequently used to prepare welded joints for painting, powder coating, plating, or other finishing processes. Surface imperfections left behind after welding can prevent coatings from adhering properly and may become visible through the final finish.
A carbide burr tool is widely used for deburring machine parts because it provides fast, precise removal of sharp edges and unwanted burrs that are left behind after cutting, milling, drilling, or turning operations. During machining, small fragments of metal often remain attached to the workpiece, forming rough edges that can be sharp, uneven, and potentially hazardous. A carbide burr tool, when used with a die grinder or rotary tool, allows the operator to carefully shave away these imperfections without altering the critical dimensions of the part. The hardness and cutting efficiency of carbide makes the tool especially effective on tough materials, such as hardened steel, stainless steel, cast iron, and aluminum, where burrs can be difficult to remove using hand files or sanding tools. In addition to improving safety, a carbide burr tool plays an important role in enhancing the overall quality and functionality of machined components. Burrs and sharp edges can interfere with part assembly, cause improper seating of components, or lead to premature wear in mechanical systems due to friction and stress concentrations. By using a carbide burr tool to smooth and break these edges, manufacturers ensure that parts fit together more accurately and function as intended. This is especially critical in precision industries such as aerospace, automotive, medical device manufacturing, and tool and die work, where even minor surface imperfections can affect performance or reliability. A carbide burr tool also helps improve the final appearance and finish of machined parts. After primary machining operations are completed, surfaces often require secondary finishing to achieve a clean, professional look. The carbide burr tool allows operators to blend rough transitions, smooth sharp corners, and refine edges so the part has a more uniform and polished appearance before coating or final assembly.
Thanks for watching. If you're looking for high-quality American-made carbide burr tools that are built to cut faster, last longer, and help you get the job done right, visit our website today. We keep our American-made carbide burr tools in stock and ready to ship, with same-day shipping available on orders placed before our daily cutoff time. Whether you're working on metal fabrication, porting, welding, automotive projects, or precision grinding, we've got the carbide burr you need. Visit our website and order yours today.